Hey everyone, in the last video we have discussed about that how we can insert any value within a BST. In this video we'll talk about that how we can search any value from a BST. Let's start. So for searching any value, at first we have to check that a tree is null or not. If a tree is null, it means we don't have any value within the tree. So at first we'll check that tree is null or not. So at first what we have to do, we have to check that tree or the subtree is null or not. If it's null, it means we don't have that data within the binary search tree. Then we'll simply return false. Else if item is less than root, then we'll perform the search operation recursively for the left node. Let's say that we'll find 10 and the root is 20. According to the rule of BST, the 10 will be at the left subtree of 20. Then we'll perform the search operation recursively for the left node. Else, we'll perform the search operation recursively for the rightist node when data is greater than root data. Let's say that we'll find 30. It means 30 is greater than 20. So 30 is greater than 20. It means we'll find the 30 at the right subtree of that node. If found, we'll simply return true, else we'll return false. So let's say that we'll find 60. So at first we'll check with 40. 60 is greater than 40. It means 60 can be at the right subtree of 40. Then we'll come here. Here we'll check that this node is not equals to null, 60 is not less than 60 and not greater than 60. It means we have found the value. We'll simply return true. True will come here and it will just return true. And let's say that we'll find 400 or 4000. 4000 is greater than 40, right? We'll come here. Then it's greater than 60. Then we'll come at the right of 60, it's greater than 70. Now, then what we'll do, we'll call the right of 70. It means we are passing the null from here. So our h equals to null. It means we don't have that data within our tree. So we'll simply return false. So this is how we can search any element within a BST. The worst case time complexity is O of n and for the average case it will be log n. At first we have to construct the tree and we have to insert some value. I have already discussed about that how we can insert any value within a BST. If you don't know, just click on the I button and watch that video at first. So at first what we'll do, we'll check that our h is equals to null or not. So it's a recursive process. If our h is equals to null, it means we don't have that value within our tree. So in my last slide, I have discussed about that if we are trying to find 4000, we don't have that 4000 in our BST. That's why we'll simply return false. So you can see that we are returning false. If our data is greater than age data, then we'll go for the right subtree. If our data is less than age data, we'll go for the left subtree. So in the last slide, I have discussed that in detail. Else what we'll do, we'll simply return true. So let me explain this again. Your whole concept will be clear. Okay, we have some value over here. Let's say that 10, 5, 100. Let's create a small tree. So x means null. So at first we'll check that h is equals to null or not. At first we'll call the search function. Search function with what? We'll call the search function with 100. So h is not equals to null. Then what we'll do? Data is greater than age data. 100 is greater than 10. So we'll go for the right subtree. So again we'll call this h right. H right means this node, right? H 100. Here we have this node. Now in this case, here we have 100, right? We are passing 100. So h is equals to null? No. Now 100 is greater than 100. 100 is greater than 100. No, right? This condition won't be executed. 100 is less than 100. This condition also won't be executed. Then what we'll do, we'll simply return true. We'll return true from here. We'll receive 2 here. Then from here we'll simply return true. So this is how we can search any value from a BST. So I think this portion is clear. If you have any doubt, just write in the comment section. Now we'll do the hands-on. So at first what we'll do, we'll construct the tree. I have already discussed about this thing, how we can insert the value. If you don't know, just click on the I button and watch that video. And this is the else function. So what it's returning the boolean value. So if we don't have the value within the tree, we'll simply return false. If the data is greater than the root data, then we'll simply go for the right subtree. Else if we'll go for the left subtree if data is less than our root data. If we found the data, then we'll simply return true. So yeah, let me compile this code. I have used the switch case. You can take a screenshot of this program, or you can go to my GitHub. You can find all the codes. So let me compile the code. Yeah, let's say that 100, 200, 50. We have inserted 3 values. So in this tree we have 50, we have 100, and we have 200. So let me search 50. 50. So we have found the data within the tree. So let me search 1000. So do we have the 1000 within the tree? We don't have 1000 within the tree. So you can see that we have got that item not found. So let me search 100. Item is found. Let me search 200. Item is also found. Then let me search again 900. Item is not found. So this is how we can perform the search operation in a binary search tree. If you have any doubt, just write in the comment section. See you in the next video.